Is Professor Luca de Alfaro from UC Santa Cruz. Luca was around here for quite some time, so many of you probably have seen him or are already friends with him. He did receive his PhD from Stanford University in 1998, was a postdoctoral fellow here at Berkeley for 2 years, and then joined the UC Santa Cruz faculty in the year 2000. Luca's work involves reputation systems, that is collaboration on the web and beyond, embedded software design, and formal methods for system design, and will tell us today how much or how little we are able to trust Wikipedia. So let's give Professor de Alfaro our usual research exchange welcome. Luca, thanks for coming.
Thank you very much. Does the microphone work fine?
I don't think you're on the house sound system.
Okay, then I will pretend that it works. Thank you. Yeah. So this is a Wikipedia page. We all love the Wikipedia, or I assume most of us love it. It's a wonderful source of information. It's free. And it grew in an incredible way since it was started in year 2000, I believe. The reason it grew so much is that anybody can edit it. So if you happen to be the expert on a particular field of knowledge, then you can go in, you can notice that the page does not contain everything you know about it, and you can edit it and improve the page. So the Wikipedia is able to essentially suck in the knowledge from everybody in the world, or everybody who cares to edit it at least, which is a very large number of people, and has been able to grow very fast. Now the flip side of it is that since anybody can edit it, when you visit it, you do not know exactly who wrote that information and whether it has been checked or how reliable that is. So, for example, we see in this page that there is a typo and there is an inappropriate expression, right? So we want to be able so I cannot tell you how much to trust the Wikipedia, so I will not give a figure. What I want to tell you is how we have tried to build a system that tells you word by word how much every word of the Wikipedia has been checked or can be trusted. Okay, so of course it will be an approximation. It's a purely algorithmic approach, but you know we found it to be fairly useful and fun, and so we hope you will like it. So the idea is this: we want to compute a figure of author reputation and text trust. So author reputation has two purposes. One is, we hope at least, that it will promote constructive behavior on the Wikipedia. The other purpose for us is that we wanted to provide to us information on how reliable an author has been in his or her contributions. We will also build, on top of the author reputation, a notion of text trust. And the idea is that we wanted to have a guide to the text reliability and provide alert to text tamperings. So if you try to for example, erase some information that used to be there, or reorder it in such a way that it says another thing, we want to warn you. Now these two purposes are slightly at odds one with the other, okay? Because sometimes you have to provide a warning for some change that happened, even though the text is reliable after the change. But we essentially compromise between these two. So I will talk first about the author reputation system. And the idea is this: there are many reputation systems that you see around, and many of them are based on user-to-user comments. Like the eBay one, I see you are a good seller, I'm a good buyer, we are all happy, and maybe otherwise we complain, etc., etc. Ours is not a user-to-user driven reputation system. Our system is driven purely by algorithmic analysis of text evolution. So what we do is this. Suppose suppose there is a Wikipedia article in some state. Suppose A comes and does an edit. So the blue part is what A changed. Suppose that afterwards B comes, keeps what A did, but modifies some part. The green, yellow and blue is green in colors, right? So modifies some part, adds some part of her own, and then keeps the rest of what blue did, of what A did. Then this is essentially a positive comment on A's work. Now, if you keep it instead of undoing it, then you are essentially praising the person who did it. It at least passed your criteria for acceptance, okay? Now, if C comes and says that, no, actually what A did was way better, he can revert it to A's version. And in so doing, C will give a negative comment on B and a positive one on A. Okay, so that's what we will be doing. Now, how to measure the contributions, I will tell you more in detail, but this is essentially the gist of the idea. So why do we want content-driven reputation? There are a few reasons. One is that we do not wish to change the Wikipedia user experience. There is a lot of debate right now when you build one of these web systems, which are the web systems that are successful enough so that people love them and choose to contribute to them, Wikipedia, YouTube, many others, and which ones are in fact the ones that will not work. Okay, so we do not want to change what worked so well in the Wikipedia, because I'm not sure we know entirely what would happen if we did, right? And if we introduced heavy user-to-user comments in an extensive way. We also wanted the system to be fairly relaxed and invisible. We do not want to add antagonism to the way people contribute to the Wikipedia. Also, another point is that everybody votes. There is a different measure of dedication in people when they contribute to the Wikipedia. If you make it a voluntary thing to give comments on each other, then you are bound to get more comments from the people who feel more strongly. And that can be a good or a bad thing. The question is a bit open. It's less prone to reputation wars. This because I cannot say that you are a fool without undoing your content. And if I undo your content, people who come after me, if they put it back, they will be hammering my reputation and increasing yours back up. So I cannot, it's not a system in which I comment on you, but the comment is hidden. Here the comment is related to the content evolution. I cannot, I cannot insult somebody without changing the text. And the text is visible to everybody. Okay? And the biggest reason also is that we have the data. When I started this work, nobody at the Wikipedia knew me, and nobody would have surely let me change anything at all, right? So with a content-driven reputation system, I could start my work using the whole Wikipedia history as my data. And we do not particularly want to display reputations, actually. Maybe we will display them to the owner, but not in general. We do not want to create more antagonism on the Wikipedia. So what are the goals of the reputation system? Well, one is prescriptive. You want to encourage good behavior. Descriptive, we want to get information about the authors. But I wanted a quantitative criterion to know whether I was doing good or bad. There are a lot of reputation systems that you can dream of. And I wanted to be able to attach a number to the quality of mine. And so I wanted to study the predictive value of my reputation system. So if you know somebody's reputation, how much does that tell you about the quality of the future contributions of that person? And the way I do it is this. So this is a Wikipedia history. So there are many articles, and a user may do many edits on these articles across time. And I wanted to look at each one of these edits in isolation and say, OK, fine. The author A has had some reputation accrued in the past. How much does this reputation accrued in the past predict the longevity of the edit? So how long the edit will last in the Wikipedia. So this is my quality criterion for the reputation system. So I can do all the training and all the algorithmic evaluation using this criterion. So let me tell you how I built it. I decided that there were, I say I, but it's really Bo Adler and I who did the initial work, okay? So we thought about it, and we thought that the best is to have measure contributions in two ways. One is text and the other one is edit. The text one is the more obvious one. So we measure how long the text you insert lives on. The edit is because not all you do is adding text. You sometimes rearrange text, you undo spam, you do many things that do not create a new text, and we wanted to capture those as well. Okay? So to measure text contributions, we do a word-by-word analysis of the whole history of every article of the Wikipedia. Okay? So we have some text analysis engine in the background. And whenever there are new words, we tag them with a revision number or version number in which they were introduced. So we know precisely in which revision each word was introduced. Okay? Then we look at the following. Somebody added this text, and in the future, due to other people contributing to the article, this text, only some amount of this text may remain. So to compute a figure of edit longevity, we approximate the amount of text remaining by a geometric distribution, a geometric decay distribution. And we use its decay coefficient as an estimate of how long-lived your text is. So if this alpha geometric coefficient is close to 0, then it means your text was almost immediately removed. And if alpha is close to 1, your text is very long-lived. Okay, so this gives us a measure of the text longevity. We do all sorts of tricks, of course. We take care of eliminating the horizon effect if the life of the article is limited, etc., etc. There is a lot I'm sweeping under the carpet. Then we use a reputation update rule. The formula, I skipped it. I tried to keep this formula, this stock lightweight on formulas. All the formulas are in various papers. I will give you at the end the references, okay? But the gist of it is that when a subsequent author, AJ, finds the text introduced by AK, the reputation of AK is increased by an amount that is proportional to how much text was left and the reputation of AJ. Okay? It's important to keep into account the reputation of AJ, because if AJ is, for instance, a spammer who has very little reputation, then it doesn't really matter what the spammer does to the system, whereas the regular users are those who carry more weight in their judgments. Okay? So there is a formula, and I can tell you that the formula that I don't show is full of coefficients, and I train these coefficients to maximize the predictive value of reputation. Okay? And this is explained in detail in the papers. Regarding edits, I do the following. So we do the following, I should say, sorry. I measure the edit distance between revisions. Okay, so there is the revision done by K, which is the one of which I want to know the quality. And I compare it to the immediately preceding revision and to an arbitrary revision in the future. Essentially, the picture is this. This is a judge and has to say, is this improvement good or bad? Right? This is the edit done by person K, and we want to know whether that's a good or a bad thing. Okay? So what we do is the following. Consider these situations. In this case, the edit done by K brought the page closer to the future. In this case, instead, the edit done by K brought the page farther away from the future. Okay? So, of course, the person sitting in the future, this judge J, everybody believes that one is right, right? And so J believes that he's right, or she's right, I don't know. And so she will say that this edit from K-1 to K is good if it brought the page closer to what she thinks is the correct version. Okay? So this is a very simple idea. And so based on this idea, we compute an edit longevity, which is essentially the fraction of the work done by this person K that went into the direction of the future. Okay? So I divide the shortening of the distance, so the difference between this distance and this distance, how much it became shorter, divided by how much work was done. So if you get a score of 1, it means all the work of K was in the direction of the future. It's a beautiful thing, everything was kept. It doesn't mean that the page wasn't changed afterwards, right? But it means that in terms of edit distance, it became closer. If instead what K did was entirely reverted, then you get a -1, because essentially all the work was in a direction that is completely different from the future. Of course, this is an n-dimensional space, of course. I mean, the edit distances are not a finite dimensional, okay? But it doesn't matter. And so there are various consequences of this edit figure. It actually works incredibly well to pick up reversions. So as a side effect of these, we have a complete analysis of everybody who reverted everybody else's text on the Wikipedia for all the articles. This is a trove of information. We are only beginning now to analyze it, and if there are ideas on what to do with it, it's actually information we are slowly making available. Slowly because it's a big amount of information, and so we still, we are still scrambling up with machines, storage, and servers a little bit. But in principle, this is all available. And actually, we'll release the software, so you could even run it on your own, right? so this is one consequence, that we know all the history of quarrels on the Wikipedia on any possible topic. The other consequence is, of course, that we use these to update reputations. So if this figure of merit is positive, the reputation of AK is increased. And if the figure of merit is negative, then the reputation of AK is decreased. Okay, and again, there is a formula that takes into account the reputation of J. This is important because if I am a spammer and I completely erase your contribution, since my reputation is 0 as a newly registered spammer or newly unregistered spammer, I don't know, since my reputation is 0, I will not be able to bring down your reputation by just deleting the whole page. Okay? So, so this is it. And I love tables of numbers and rather than graphs. I'm sorry for you. And so I want to give you some measure of the predictive value of this reputation. So this is after we tuned the coefficients. We tuned the coefficients on the 2005 edition of the Italian Wikipedia. I'm Italian, so I could test all the algorithms by reading it, right? And it was small enough that that we could process it in a short time on a single CPU. It was no problem. This evaluation instead is done on the 2007, February 2007 edition of the English Wikipedia, which I think until recently was the most recent full dump available. I think in these days they are making a new dump that should succeed, but after the February one, there was a gap in available information from the Wikipedia. So let me tell you what this says. So the first column is separate from the others. It tells you how many users are, no, not really how many users, but how many edits belong to each reputation bin. You see that people without reputation are responsible for 17% of the edit change. Then there is not much because people tend to gain reputation quite quickly. 44% of the edits are done by people of top reputation and so on, okay? So you see there is not a lot of intermediate things. So this is not what I expected, but is what the training gave me. My reputation system does not really separate the superstars from the just good. It really separates the novices from the somewhat experienced and up. And I didn't know that this was the answer. This is what the algorithmic training gave me as a result. This reputation system had a lot of parameters to tune. It could have looked very different, this distribution of user reputation, but this is what gave me the best predictive power. So this is the percentage, let's look at this column, for instance. This is the percentage of edits by these people in this reputation range that ended up having a longevity smaller than this. Okay? So maybe we can look directly at the, if the longevity is smaller than minus 0.8, this means the edit has been reverted. So this means for people that have no reputation, 73% of the edit work is reverted. For people of top reputation, 1.14% of the edits are reverted. And this goes on across all the measures. So for example, if you want to look at the edits that are just slightly negative, and a lot of good people do things that are slightly undone. But you still see that about 90% of what users of reputation 0 do ends up being undone, whereas only 5% of what users of high reputation do ends up being undone in some measure. This is even too good a figure, in my opinion, because this also encodes and is not as good, I can tell you, in the French Wikipedia, which we also studied. Part of this is that it has become very difficult, as only one of you has tried knows, to contribute to the English Wikipedia. If you write things slightly wrong, you get hammered. Okay? At least that's my experience, I have low reputation myself. I know my reputation. Okay? So let me define these as low reputation, the two bottom bins, and these as being short-lived, so what really is reverted. Then I can summarize the performance as this. Low reputation authors account for 18% of the edits, but for 82.9% of the short-lived edits. And an edit has a 5.7% of being short-lived, but this raises to almost 50% if it's done by somebody of low reputation. So, in information retrieval theory, these are called precision and recall, but this is not about information you have already seen, which is a classical search problem. This is a prediction problem on human behavior, so I think these figures are fairly good. Now, suppose we have something that has the reputation of the authors. How do we build out of these a trust system for the Wikipedia? So the idea is this. We wanted to have new text that has a reputation, that has a trust tied to the reputation of the author. Since the text is new, nobody has yet looked at it, and it seems the only information we have to go by is the reputation of the author, right? So we want to make sure that if the text is revised, the trust of the text can rise. Because if experienced people look at the page and leave the text there, it means that they find it okay, essentially. And so the trust of the text should rise. You may at this point ask, hey, why don't you take care of the page views as well? And the answer is that until recently, this is data that was not available from the Wikipedia. There are two reasons for this. The first is that they use a very distributed organization to serve the pages, so there was no unique place where to look for the logs. You know, they have squid servers that mirror the information, and so you would have to collate the information out of all those sources. There were also many privacy concerns, right? They don't want to, of course, to give anybody the IPs of the people looking at any specific information. And the whole processing was not in place. Now, maybe the situation will change, but so I base my algorithms purely on the edits, which is something that instead is public, because you can look at, you know, which edit happened on every article. And we also want to alert visitors to information tampering. So, and as in some previous work that was done at Stanford by these people, we wanted to display trust via background colors of the text. Okay? So, orange for untrusted and white for trusted. So, I will now give you the algorithm in pieces for computing the trust. This is a bit out of a hat. Okay, just like the reputation system, if you will. It's just, you know, my sitting on a couch and dreaming it up. And so also for this, I will give you a qualitative performance measure that relates to the predictive value of the trust, okay, to justify why I did it this way. And it's probably not the only way to do it. And so I'm curious to see, you know, how it can be made better. But what we thought was the following. So, if you have a text insertion, the text inherits the trust from the reputation of the author. Okay, so if the author is low reputation, this will be quite orange in background. This looks white to me. It's bizarre. It should be a pale shade of orange, because the point I was trying to make is that if the text is by a high reputation author, its background is still not white. Okay, it's still some shade of intermediate shade of orange. It means I think, you know, the reproduction of the projector is not color accurate. Because what I wanted is this, that fully white background can come up only as a result of consensus. So a single person cannot inject a text that appears white in the, with white background. Okay. Full trust can only be achieved via consensus. I also wanted to provide an alert when people rearrange blocks of text, okay? Because you can change the meaning of sentences if you arrange words in the sentence. Or if you rearrange, for instance, the order of paragraphs, you still change the information. So I wanted to have a clear warning that something had happened. This is also very important, you know, if you just cut out a piece of text. So what we did is the following. Suppose you have some blocks of text that get rearranged. This is a border between two blocks of text that did not used to be contiguous. These used to be contiguous already, right? But these two not. So at the borders between, at the new contiguities, okay, the discontinuity borders, if you want, I have some trust value that is actually equal to what the value of new text by this author would have been. Essentially, it's as if the author inserted an empty word of its of corresponding trust value here. Okay, and this fades gradually towards the interior of the block. So you will realize that my system has a lot of coefficients that need to be tuned, right? For example, how fast is this fading? How much reputation do you inherit? And all this is done via training in order to maximize the various figures of merit that I will explain you later, okay? Just in the reputation system. It's all a problem of, I mean, I set it all up as a problem of learning the right coefficients, okay? Okay. Now, after this new text and these rearrangement effects are done, we do the following. So suppose that this is a trust of the existing text in a page. So this is the text of the page, and the trust may vary across the page. And suppose that this is the author's reputation, okay, this dashed green line. Then what we do is the following. When the text has lower reputation and when the text has lower trust than the author's reputation, we raise the trust of the text somewhat, okay? So the formula is something like this. We have again yet another coefficient to raise the trust of the text. And here we experimented in many ways, because at first we wrote this algorithm, and then we thought this is really too naive. There is somebody who edits at the bottom of a big page, and also the trust of the text at the top of the page raises. This is a bit unreasonable. So in our code, actually, we implemented some beautiful, beautiful is self-aggrandizement. But we implemented some algorithms that look at where the edits are made and identify the section of the articles that the person is most likely to have looked at. And so that we raise the trust of the text in greater proportion in the places that the author has most likely touched, right? And this is beautiful, in my, and I say this because I say it is beautiful because I cannot say that it works better. So the numerical results were essentially unchanged within a couple of percents. And the reason is this. On a page, when somebody edits a page, most often at steady state in the Wikipedia, the whole page is highly trusted, except for a portion that is still unstable. You most likely edit the portion that is unstable. So outside of what we already mark as where you are likely to have looked, there is not so much reputation to raise, and so trust to raise. And so that's why, numerically it's very difficult to validate these author attention models. So still, we left them in because we felt good about them, but numerically they don't improve performance. Okay? So now if we look at it all together, this is what happens. So there is some trust values on the text, and then somebody comes in and does a reordering, which A keeps its place, E is new, and B and D gets joined, and so the reputation does this. B and D, it's a new frontier, it's a new border between them, so the reputation is brought down to the value of new text. E is new text. So these two values, this and this point, are the same. Then there is this border effect at the border of blocks, and away from the border of blocks, you can see that the reputation of this part of D and this part of A raised. Okay, so I mean, this is just the result of putting all the components of the algorithm together. Okay, and you may say, very well, but how does this look like? So this is the page on Italian cuisine. Okay, after the coloring. So you may notice it's not perfect. It picks up some extra stuff, but it works fairly well. Okay, so this is an article on cheerleading. Okay, and what I find interesting is this. So here is, of course, in a text that was inappropriately added, but this text is instead accurate. I mean, it is part of the trusted version of the article. So some people tell me that I should combine my algorithms with the word spotting or with the semantic analysis, and so far I haven't done it. There are a couple of reasons for that. I mean, there are 3 reasons for that. One reason is that my tool, as it is now, is language independent. As long as I can chop up a text into words, I can apply it. And this is a big advantage. The Wikipedia is actually a family of encyclopedias in many languages, and so I can run my tool on most national Wikipedias. Another reason is that it's simpler. right? If you get good results without worrying about something, then it's better in a sense, because you know, you don't need to worry about it. And the last part is, I don't know how to do it. So in a sense, if anybody has great ideas on how to improve the trust computation, especially now that the tool is available in open source, well, you know, go ahead, try it. But I wouldn't know anyway how to do it. Okay? So, word or sentence level. There is some ideas that trust should be computed at sentence level. I prefer at word level because it gives me much more of a pinpoint information of what is going on a page. It's much more useful if you look at it. This is a long sentence. If you just knew that from here to here there is something unreliable, well, okay, maybe you can guess it from the word devil, but if somebody tampers with information a little bit, you would not be so sure about it. Okay? So, another application of this trust that we are exploring, but you know, we have not yet implemented, is to compute a general quality figure for a revision, so that if you want, you can get a high-quality snapshot of the Wikipedia automatically. This is, of course, quite interesting. You know, you can burn it to a DVD and give it out to elementary schools or do things like that. So this is quite interesting, but is not yet among the things we have done. Okay, so we are working on it. Okay, so this also enables you to find the non-obvious tampering with the page information. For example, this is a sentence that appeared on the Wikipedia. This is a new Prime Minister of Denmark. Okay, and actually the J is not there in the real name. And the point is that a fjog is a fool or goof in Danish. I hope, is there any Danish in the room, actually? Is this correct? I think so, but I had a bit of trouble checking, finding an online Danish dictionary while preparing this talk. Anybody who knows? No, not a common language. So, and so, you know, since it's not such a common language, few of us would have spotted actually the inaccuracy. And this is important if you want the Wikipedia to be more, to be perceived at least as more robust, right? You cannot go in and delete a sentence or a paragraph out of an article without leaving some trace. You cannot go in and change some spelling or some date by a small amount without other people noticing, right? So how do we evaluate the trust computation? So one idea is to have people tell us what they think of it. And this idea does not really work. It's too long, too boring, and too expensive in terms of time. Boring because everybody is fascinated by the Wikipedia, but you know, I had actually to look at hundreds or thousands of these pages to debug my algorithms. I can tell you it's not fun. It's interesting for the first 5, it's okay for the next 10, and then, you know, it's like eating the soup you don't like. So another reason is that it's not suitable to algorithmic optimization. I wanted to be able to train my algorithms to improve the figure of merit, right? And I cannot do a user test every time I change a coefficient by 0.1. And another thing is that people disagree. People disagree. We ran some informal comparisons between us developers of what we thought of the various merits of some changes. And in some cases, we really had different opinions on whether a change was good or bad. For a typical case was this. There was a page on Mussolini in Italy. And somebody added a section on his philandering. That was quite large compared to the rest of the information. And then some of us thought, this is great. When the rest of the page will be expanded to its proper length, the article will be balanced and will contain a variety of information. Some of us thought, this is bad. This puts the emphasis on the wrong part of his life, right? And so, you know, how do you judge? And so we wanted really some algorithmic measure of quality. So the idea that was explored before by this Stanford group, so we sort of refined the evaluation criteria, but the classical idea was already there. That is, if the text is stable, it should not change very much in the future, okay? And so based on this common idea, we looked at 3 criteria that, you know, are specific to our work, I guess. So we measured and we said that text in the bottom half of trust values is only 3.4% of the text, but it corresponds to 6% of the text that is deleted in the very next revision. So if you're in the bottom half of trust values, you have much more unstable than general text. Also, we know that text in the bottom half has a 1/3 probability of being deleted in the next revision. But the probability of being deleted is only 1.9% for general text. So, so these two together, this gives you the precision. So suppose I raise a flag if your trust is below the half. Okay? This tells me the probability that if I raise the flag, the text will really be deleted. And this tells me the probability that if the text is going to be deleted, I have flagged it as low trust, right? So these are precision and recall. And I think they're fairly good for, again, for a prediction problem. It's not a retrieval problem, it's a prediction problem. So these data are obtained by analyzing 1,000 articles with at least 200 revisions. We didn't want to analyze articles with very short revision histories, because essentially because of the graph I'm showing in the next slide, we wanted to be able to measure something about the longevity. So this is perhaps the conceptually more interesting graph. So suppose you do the following. You take a word completely at random in the Wikipedia, actually in these 200 revisions we have selected. Okay, so it doesn't matter where, but you close your eyes and pick a word. Then you look at its trust. The word may be already living for some time in the Wikipedia, it doesn't matter. But you pick the word, you look at the trust, and you look at in how many successive revisions the word will live. Okay? And so you want to know what is the correlation between the trust value of the word you picked and the expected life of the word in the system. And we compensate for all things like, limited horizon, because, you only have 200 revisions, you don't have infinity of them, etc., etc. So we do this analysis compensating for all these phenomena, and this is a graph we get. So we see that there is even though we would like perhaps a smoother graph, but there is clearly a positive correlation between the trust of the word and its expected life. Okay? And so we use these various recall, precision, and some other criteria in order to evaluate, to optimize all these coefficients we have in the end. Okay? And I would like to show you what happens to text. Sort of fast forward in the history of an article. This is again about Denmark. And this is somebody who has just introduced some text about the executive branch. This has been introduced by an anonymous author. By the way, it seems that anonymous authors are responsible for a large portion of the new content or informative content of the Wikipedia. And then others are responsible for cleaning it up and reformatting and improving it. So this is what we will see here. No? So this text is new and is a low reputation. And as people edit it, these are consecutive revisions. Unfortunately, this is not quite white. Okay, the projector is missing some color, but you see that it became white in the span of. Well, you will have to look at the top, but essentially eight revisions in total. Okay, so again, how quickly should it become white? This is open to question. It is very difficult to come up with an answer. It depends essentially on how paranoid you are about the risk of having some information tampering. And I mean, among the authors, I was the one in the end who ran all these optimizations, and I really did not know what to do. So the only way in which in the end I could settle on some coefficients was to look at the two figures of merit that are not actually part of the talk. So I just explained to them orally. I wanted to know how wide on average is the text of the Wikipedia. So essentially I wanted to know that 90% of the text was wider than a certain point. This is very pragmatic, okay? I wanted you, when you land on a random revision, not to see too much orange, because otherwise you just drown in the information, okay? So in particular, I wanted to have 90% of the text be above reputation 7. Reputation goes from 0 to 9, and I wanted at least that. And then I tried to maximize, I tried to minimize the trust of the text that was going to be deleted in the next revision, where I compensated actually for deletions that happened due to spam, that happened due to vandalism. So I have a method for deciding ahead of time which revisions are vandalism, and I do not take those into account. Because the problem of taking those into account is that you may have perfectly good text, and then a vandal comes and just erases it all in order to introduce spam or links to his own sites. Okay, so I wanted to avoid that. So that's the way I optimized it, and people seem to be happy with it. but I do not have a general answer of how this should look like. This is a problem of human expectations about the information you're looking at, and also how what is the purpose for this trust labeling? I mean, will people be looking at it only when they are paranoid about information, or will they more generally look at it, and so you want a lower level of warning? So we have a lot of data. The code is available. We are slowly trying to make available all the data, but it's a very large amount. So we have a little bit of problems of servers and disk space. If anybody is interested or has bright ideas what to do with it, we are very open to cooperation of all kinds. So we have a live demo in which we have colored the whole Wikipedia. Up to the 2007 snapshot, okay, up to this February of 2007 snapshot. We will now be working towards two goals. One is to do it for the newer snapshot, but especially we are working on a real-time system that is able to color the text and assign reputations as edits are made, so that it will get a feed of information from the Wikipedia, a real-time feed of information, and provide this coloring in real time. Okay. And we actually would like to deploy this on the live Wikipedia. So we don't know whether this is going to happen. It's out of our hands. But the idea would be that the Wikipedia is looking for various methods to increase its reliability, and the proposal would be to have a small tab somewhere that you can click on, and then the text of the page would be replaced by the colored version. I mean, we are a bit far away from this. We need first to have the online system working, and then we need the Wikipedia to approve these and review our code. But we are optimistic. So we would like also to thank CITRIS for the support. This started as an impromptu idea without any funding, and we started to work on it out of a whim, really. And without CITRIS support, this would not have been possible. So, okay, I'm perfectly on time, actually. Thank you for your time.
Thanks for a great talk. Do we have any questions today? All righty.
So this algorithm depends on a whole number of coefficients that you were mentioning.
Yeah.
And those coefficients are derived by training on a set of data.
Yes.
If you used different data, like for instance, like the February 2007 version versus the Italian version, how well do the coefficients compare? Or how well is the performance if you use like one set of coefficients on a different set of data?
Yeah, this is a very good question. So the unfortunate thing is this, that if I looked at the space of values for the coefficients, I found several maxima that were close in value. They did not immensely, so they depended on which Wikipedia I was using, okay? Because, for instance, the Italian Wikipedia has fewer versions than the English one. So the figure of merit was different, but the maxima of the coefficients more or less matched. The hard problem I had was to choose among these local maxima, because one gave you, a higher recall but a lower precision, and the other one vice versa. So there was this local maxima, and somehow I had to break the tie, based on nose, friends' opinions, common sense, and looking at a lot of special cases. So.
So to follow up with that, would the idea be that you develop a set of coefficients from now, and that will be the set of coefficients for the rest of Wikipedia's lifetime, or is there some sort of like adaptation that you would expect to need?
We very much want to develop the adaptive algorithms, but the adaptive algorithms are not so much important for the Wikipedia. For the Wikipedia, you can adapt once a year and you are fine. I mean, it's stable enough. The adaptive algorithms are very important for something like the Indonesian Wikipedia or the small Wikipedias that are still evolving. It's in the initial phase that you need that the most. And so that's what we are looking at, but we don't have results on it yet. Yeah, it's very interesting. It's necessary.
As you mentioned, a large number of the edits come from anonymous users. Do those actually factor into your calculations for trust, or are your calculations based only on registered users?
The calculations for trust include everything, because once I look at the text, for example, once I look at this graph I showed, where is it, a few slides back, here, okay, for example, for this graph, I do not I do not pick the word knowing what the original author was. You know, people have reviewed the word anyway, so they have anyway influenced the trust of the word. So this is just based on the general population of the text of the Wikipedia. In my figures of merit for author reputation instead, in the paper, I distinguish between the case in which you exclude anonymous and you include anonymous. And of course, my system works a little bit better if you include anonymous, just because they shoot themselves in the foot, right? By being anonymous, and since the spammer are anonymous, well, you know, then yes, it's easier to predict that any vandalism will be from anonymous. But the problem is that a lot of good things come from anonymous as well. So, for trust, I use everything together. For reputation, is separate.
Right now with journals, I mean, everybody says don't quote Wikipedia, and they're probably right. But could there be a way, there's a lot of good articles that come out of Wikipedia too, it's just the variability. But is there a way, for instance, that academic institutions or other noted societies could be entrusted to comment on some of these articles and kind of set a seal of approval or validity or set a standard that then they could also review other articles and kind of say this has been approved by these societies or these organizations with a certain level of expertise?
So
and that could
the Wikipedia is developing an extension that is called the stable revisions, by which people of different Wikipedia authorities, so to say, will be able to flag some revisions as validated, okay? And especially the German Wikipedia wants these, and these will be available. You will see it. I mean, it's in the deployment plans for the Wikipedia. And these, if this work on trust happens, it will be in parallel to that. There are pros and cons to each one of these approaches, right? So this approach is not the trusted revision, the stable revisions is not based on academic excellence, but ranking the Wikipedia, which though means that you have proved to be a reliable source of information in the past. One of the problems of these stable revisions is that you flag a revision as stable, and then the revision changes. So, you know, they will tend to lag behind if you don't inject enough human time in them. And so, you know, we believe currently that it's best to have both approaches. We are going to look at ways to integrate the two approaches once they both work, you know, with the fault being on mine, which is further behind in the development line. So, for example, if you flag a version as stable, then the trust should probably increase, things like that. But there is no plan. I mean, it could work, your idea. Or you could even think of a new way of publishing scientific papers in which people put the papers up, and then people can essentially vote on them or cite them or you know, or modify them in some way or etc. But I'm having enough of a hard time already making people in the administration believe that the conference papers matter in CS. You know, you can rather than journal papers. You can imagine if I don't know. You know, yeah, there are many things that should be changed.
So I have a question here from UC Davis. It says, my question concerns the repercussions of introducing your technique. For example, wouldn't low trust edits become more likely to be replaced in the next revision? I would like to know, oops, hang on, they added another question. I would like to know whether your numbers support or refute this.
Yes, so unfortunately my numbers do not say anything about it, right? Because this is not on the live Wikipedia, and so people cannot react to my trust figures by editing. It's a very good question. It's to be observed that high visibility Wikipedia pages already have people who watch them, so that at any edit they get an email and then they go check it. So this will make it much easier, of course, for anyone to spot the unstable regions of pages. Now, will the effect be positive or negative? I tend to believe it will be positive, because it will be easier for people to pick up which section of the page may have changed if they want to improve it. But I do not have data on this at this point.
There's one more from Davis, too. It says, can a user's reputation vary by category of the topic? That is, John might be an expert and hence reliable on cooking, but might not be as reliable in fixing the blender. Should his edits on cooking be made as low trust as those on fixing blenders?
Yeah, this is a very good question. And in fact, I had a student who began this work, then she decided to do something else for her research. And then now another student is looking at this very question. So I don't have the full data to give you. But essentially, it seems that the category does not matter very much. What matters most, if you want me to put it as a half joke, is your ability to keep your mouth shut. So if you know what your limits are, you generally do not tend to edit things you don't know about. And this seems to be the distinguishing factor that we may be measuring. We tried to see it, but we see a very small category effect. So if we take into account categories, the performance it does not significantly change. In some cases, it changes for the worse. Just because some people do a few edits in a particular category, that it does not take into account the great reputation in something else they have done. So it's varied, but overall it's not great. Yeah.
A question over here.
Hi. So it seems like one shortcoming of current media is that people who have a lot of resources tend to define what's true. So it seems like this could be a problem with Wikipedia in the future. Is there any sort of normalization you can do for example, how many computers someone has available, or basically access to resources in determining how truthful some form of information might be?
So there are two parts to the answer. The hard part is this. What I swept under the carpet during this talk is the problem of how to make this robust to attacks. I swept it under the carpet because we have new work on this topic, but we haven't published it in any form yet, and so we will be, we will be looking forward to doing this work and writing it up. And we think we can be made robust to attacks, such as hitting the same page often or these kind of things. The other question is more. I think actually this can make things more democratic, but it depends very much on how the community of people will receive it. So the illusion that the Wikipedia is democratic, even if you have few resources, is basically an illusion. There are people that have much more time in their hands than we can possibly dream of. And there are some of these people, who dominate the evolutions of some set of pages, because whenever they see an edit they don't like, they revert it. And now, this is an algorithmic method, and so it could perhaps improve the situation. Now, most often these groups of people do an excellent job. Not always, and so there are some issues in the community of people in the Wikipedia, as in any community, really. This can perhaps help providing an objective criterion, but yes, this does not solve the problem that if you are a poor person with not so much time in your hands, you write an article and there is this clique of people which have accrued high reputation in the past that all the time hammer you, then your reputation will not grow. I tried to make up for this by sort of devising the rules of reputation update in a particular way, but this effect, you cannot eliminate it. It's the nature of how the medium evolves.
We have one question here from Santa Cruz. Says, you stated that reputation does not vary with topic. How do you prevent me from creating a random article, then editing it over and over, giving myself a higher and higher trust value? Then I can raise my trust as high as I want and then go vandalize articles again and do it at the high trust level.
So yeah, this is what we will cover in the next work on how to make this resistant to attacks. Basically, even right now, you cannot give your reputation to yourself. So you will need to create sock puppets. And there are ways we are devising in order to make sure that this cannot happen, but I need some time to write it up. I think it's based on nifty randomized algorithms and other stuff, but I cannot talk it now.
Do you have any more questions in the room here? Okay, well, thank you for such a great talk. Let's give a nice round of applause.